Hello students, I am SNGhorpade, faculty in mathematics department. Today we'll start with unit 3 of engineering mathematics 1, that is successive differentiation. Weightage of this unit is 9 marks. See why we are studying this successive differentiation. In 12, for the function y equal to f of x, we have studied derivatives of first order and second order, dy by dx and d2y by dx. You use those derivatives to find maxima and minima of the functions. Same way here we'll find higher derivatives like third order derivative, fourth order derivative up to nth order derivative. We'll use this successive differentiation while finding power series expansion for the series like Taylor's and Maclaurin's expansion. In Taylor's and Maclaurin's expansion we'll need higher order derivatives, as well as in M2 when we'll study tracing of curves. In that tracing of curves, to find the point of inflection, we'll need successive derivatives. Now we'll start with notations which we are going to use in this. Say if we have given function y equal to f of x, then its derivatives we denote either by y1, y2, y3 up to yn. Second type of notation is f dash x, f double dash x, triple dash x, and so on up to nth derivative of x. And third notation is y dash, y double dash, y triple dash, and so on up to nth derivative of y. So these are three types of notations which we can use to denote successive derivatives. Generally, we'll come across this type of notations y1, y2, y3 up to yn. Now we'll see nth derivatives of all the elementary functions. What is meant by elementary functions? Exponential function, trigonometric sine and cos, then hyperbolic sine and cos, logarithmic function, polynomial functions. For example, if I write first function, say y equal to e raised to ax. Tell me what is derivative of e raised to ax? First derivative is a e raised to ax. Second derivative is a square e raised to ax. Continuing in this way, we can write yn. See, for y1, we are getting a raised to 1. For y2, a raised to 2. Hence, for yn, it is a raised to n e raised to ax. Similarly, if we have second type of function, say y equal to a raised to x. What is its first derivative? All of you know it. It is a raised to x into log a. y2 is second derivative of it. What it is? A raised to x log a raised to 2. So continuing in this way, yn is a raised to x log a raised to n. Now third function, we'll consider y equal to sine of ax plus b. Its first derivative is a cos ax plus b. When I'll find its second derivative, it will be what? Minus sign. Third derivative will be minus cos. That is, alternately we'll get plus cos, minus cos, and so on. But we can't write general term in this case. Therefore, it is better to convert this cos theta into sine theta. We know that sine of theta plus pi by 2 is nothing but cos theta. Hence, to this cos ax plus b, I'll write it as a sin ax plus b plus pi by 2. We have converted this cos into sin now. Find second derivative y2. It is a square cos of ax plus b plus pi by 2. But again we are getting cos theta. Replace that cos theta by sin of theta plus pi by 2. And hence we'll have a square sin of, this whole is theta, ax plus b plus pi by 2. This theta plus pi by 2. And therefore second derivative is a square sin of ax plus b plus 2 pi by 2. When y1 is there, we are getting a and 1 pi by 2. For y2, we are getting a square 2 pi by 2. So what will be yn? It is a raised to n sin of ax plus b plus n pi by 2. All of you got it? Okay. Now we'll see for cos. If we have y equal to cos of ax plus b, what is its first derivative? y1 equal to minus a sin of ax plus b. Again here the case is after cos we are getting sin. In the next derivative we'll get cos. So what is better? Convert this minus sin theta into cos theta. We know that cos of theta plus pi by 2 is minus sin theta. Hence we can write this y1 as a cos of ax plus b plus pi by 2. Get the second derivative. What it will be? A square derivative of cos minus sin ax plus b plus pi by 2. Replace this minus sin theta by cos of theta plus pi by 2. And hence we have y2 is equal to a square cos of ax plus b plus 2 pi by 2. Therefore, we can write yn as a raised to n cos of ax plus b plus n pi by 2. Which step is important for the derivatives of sin and cos? Replace cos theta by sin of theta plus pi by 2 and minus sin theta by cos of theta plus pi by 2. Then only it is possible to write generalized result. Now we'll say fifth function, that is y equal to ax plus b raised to minus m, where m is greater than 0 and it is nothing but positive integer. Now we'll find its successive derivatives. What is y1? Minus m ax plus b raised to minus m minus 1 into derivative of ax plus b is a. We'll write this as minus 1 into m ax plus b raised to minus of m plus 1 into a. Then find y2. For y2, I'll use this step. Minus m. Derivative of this ax plus b raised to minus m minus 1 is nothing but minus m minus 1 ax plus b raised to minus m minus 2 multiplied by a square. Rewrite this expression. take minus 1 common from this bracket as well as this bracket. We are taking minus 1 common 2 times, minus 1 square. What will remain here? M plus 1. Now take negative sign common from the power. Will have m plus 2 into a square. This is our y2. Can you write yn from this? For y1, minus 1 raised to 1. M, and here it is m plus 1. For y2, minus 1 raised to 2. And m plus 1. Here it is m plus 2. Hence, yn will be, this term will become minus 1 raised to n. This product is up to what? M plus 1 and so on. For 2 it is 1. And hence for n it will be m plus n minus 1. Ax plus b raised to minus of, for 2 m plus 2, and hence for n it is m plus n multiplied by a raised to n. But if you observe it, this formula is very big and it is difficult to apply it in the problems. So if we convert it into smaller one, then it will be better to remember. See this product, m plus 1, m plus n minus 1. We'll think in reverse way. M plus n minus 1, this number is reduced up to m. We can convert it into factorial notation because we know that n factorial is n minus 1 reduced up to 3 to 1. Here the number m plus n minus 1 is reduced only up to m. So we can write this by m as minus 1 raised to n. M plus n minus 1 is the first number. Decrease it up to m plus 1 and m. I'll multiply and divide by m minus 1 up to 3 to 1 by m minus 1 reduced up to 3 to 1. Remaining terms as it is. Ax plus b raised to minus of m plus n into a raised to n. Compare these two. When n is decreased up to 1, what we call it as n factorial. In this case, we are reducing m plus n minus 1 up to 1, and hence we can call it as m plus n minus 1 factorial. Similarly, if you observe denominator, the number m minus 1 is reduced up to 1. What you can call it as? M minus 1 factorial. Remaining part is ax plus b raised to minus of m plus n into a raised to n. Please rearrange terms. So our yn is minus 1 raised to n, a raised to n, m plus n minus 1 factorial by m minus 1 factorial multiplied by, when I take it to the denominator, this negative will become positive, that is ax plus b raised to m plus n. And hence, this is final result for the nth derivative of ax plus b raised to minus m.